Hello team IGC, we are the hustlers.
Hello Team IGC, we are Team Hustlers. In India, most climate response still are manual and slow. Heat waves are handled after temperature becomes extreme, flood are manageable only once the water has already risen, and pollution alerts often come too late. Because this process depends on human monitoring and delayed reporting, our cities react after damage begins instead of preventing it. Welcome to UCSN, the Urban Climate Shield Network, an AI-powered adaptive defense system to design to make cities climate resilient. UCSN transforms a city into living, intelligent ecosystem that can detect climate threats, protect people and infrastructure, and adapt in real time. Instead of depending on manual intervention, UCSN integrates IoT sensors, digital twin technology, predictive AI models, climate simulations, automated cooling systems, and smart flood defense units into a single unified network. Our vision is simple and yet powerful. Detect, protect, and adapt. With UCSN, cities move beyond reacting to disasters and they become capable of preventing them.
After understanding the limitations of India's manual climate response, the first major innovation we introduced in UCSN is the digital twin environment. A digital twin is essentially a living virtual replica of an entire city. It continuously updates itself using data from sensors, satellite imagery, and weather services, allowing us to visualize temperature, humidity, and AQI, rainfall patterns, vegetation cover, and even flood-prone areas in real time. In traditional city systems, data is siloed, delayed, and scattered. But with a digital twin, all environment information becomes unified and instantly accessible. The system uses AI models like UNet for land surface mapping, Kalman filters for merging multiple data sources, and graph neural networks to understand the spatial relationship between different parts of the city. Like here we can see we have implemented a 3D view interactive model of the place called Anand Vihar ISBT, which is one of the most polluted areas in New Delhi. We have implemented here all the sensors, the heat maps, and the scenarios. Like as we can see in the heat map, here comes the geospatial analysis, like how is the commercial corridor and how are the UHI of that particular place. Like we have active alerts as as of now as the pollution has been increasing rapidly in Delhi. In Anand Vihar ISBT area, high pollution is detected, which is around AQI 254, railway station, metro station, and industrial pockets. Like here, we can also run simulations to pre-capture the images before implementing any methods practically. Like severe pollution morning peak, we can check, and if we run emulation, like it shows that executed successfully, and we can see here how the geopolitical map is showing us. And evening traffic haze, we can check like evening traffic haze implemented successfully. Like here we can see like these are the areas which have been generating more heat and which contributes more to the uh, global warming. Here are the real-time metrics which change dynamically when we are changing the scenarios. So let's move to another feature, which is urban cooling nodes.
So let's go dive deep into urban cooling nodes. One of the biggest challenges in India faces is extreme urban heat. Traditionally, cooling responses involve manual water tankers, temporary shelters, and direct action after heat waves have already impacted people. UCSN solves this with urban cooling nodes, fully automated, AI-driven microcooling stations designed to reduce local temperature in zones. Each node is equipped with smart misting nozzle, automated shade canopies, and evaporated coolers, reflective surfaces, and model green walls, all powered by solar-assisted microgrids. Surrounding sensors continuously measure air temperature, humidity, surface temperature, and wind patterns. Solar radiations. AI models such as LSTM predict short-term heat build hours ahead. Clustering algorithms like DBSCAN detect real hotspots, and model predictive controls ensure each node uses minimum amount of water and energy to deliver maximum cooling. These nodes activate even before the heat becomes dangerous. Similar urban cooling solutions are already deployed and successful in Japan, Dubai, Barcelona, and Melbourne, and UCSN transforms this global innovation into a scalable solution for India. Here you can see the examples like in Japan. There are different machine cooling systems in plug-in spaces. In Dubai, there are different shaded volcanoes reduce temperature by 6%, also in Spain and Australia too. Let's go to the next feature.
Flooding in India remains heavily manual with sandbags and emergency walls deployed after the water level rises. UCSN introduces smart coastal shields which act as automated intelligent barriers that rise proactively whenever the system predicts a flood or storm surge. The shields are powered by tide sensors, infall meters, river level monitors, and anomaly detectors placed across critical water zones. Using machine learning models and the models which we have implemented, like rain, thunder, temperature, clouds, waves, rain accumulation, wind, gusts, our model forecasts dangerous water events early and lifts the shield automatically and protecting lives, property, and coastal infrastructure. Technologies similar to this already save millions of people every year in Netherlands, Venice, and Japan. UCSN brings a version optimized for India's monsoon and coastal vulnerabilities. Like here, we have implemented more than 39 models to predict flood and raise coastal shade accordingly. Like here we have implemented thunderstorm, dew points, humidity, which all are functional, clear air turbulence, of wind accumulation, rain thunder, weather radar. We have implemented over 39 models to detect if there is a chance of flood. Our AI will automatically raise the flood shield and will help to protect lives, property, and coastal infrastructure. So let's move to another feature, which is the IoT sensor grid.
So let's see how our IoT sensor is well optimized and 100% sure. To support all these automated climate defense actions, UCSN uses dense IoT sensor grid spread across the city. This sensor continuously track temperature, humidity, air quality, rainfall, waterlogging, small furniture, and wind speed at extremely granular levels. Often street by street, instead of relying on the handful of government weather stations, UCSN creates hyper-local, real-time environmental visibility. The system uses sensor fusion techniques and anomaly detection algorithms to ensure the faulty and missing sensors do not affect the accuracy of the network, as the main part is accuracy while dealing with the weather. This approach is similar to the smart grid sensor deployed in Seoul, Chicago, and several Indian smart cities, but UCSN integrates them into fully automated climate response ecosystem.
Now here comes the AI command hub, which is the brain of our whole ecosystem. Like here is the neural orchestration. The command hub acts as a city's brain. It ingests data from satellite feeds, ground sensors, and weather stations using deep reinforcement learning. It optimizes the deployment of resources. For example, when a heat wave is forecast, the hub activates the urban cooling nodes. When water level rises, it deploys smart coastal shields. And when pollution spikes, it coordinates purification actions. The hub uses reinforcement learning to optimize decision making over time and Bayesian risk models to estimate the likelihood of upcoming climate threats. Like if I
So let's see our the main part, that is predictive intelligence. One of the most powerful tools inside UCSN is a predictive simulation engine before the city invests in green infrastructure, cooling solutions, and flood defenses. The simulation engine allows planners to test the effectiveness of this intervention virtually by adjusting the parameters like tree density, reflective paint coverage, and green roofs or barrier height. The system predicts how temperature will change and how much carbon will be absorbed by how much energy will be saved, how the city's comfort level will be improved. This is the powered by gradient boosting models of carbon estimation, hybrid microclimate physics simulation, and LSTM forecasting for temperature changes. This kind of digital climate planning technology is used in Canada, Germany, and UCSN brings the same analytical power to Indian cities. So by using this adaptive power, we make our India well in our weather system.
To make it more interesting, we have introduced the analytics dashboard. It is designed for long-term climate insight. It shows trend in temperature, rainfall, AQI, humidity, and energy generation over time. Zone performance scoring levels has also been included, which remains vulnerable. Anomaly alerts notify officials if unusual patterns emerge, such as an unexpected heat spike or an abnormal rainfall. This dashboard ensures that every action taken by UCSN is measurable, transparent, and backed by data. Coming to the impact dashboard converts UCSN performance into real numbers that matter. How much CO2 has been offset, how much energy has been saved, how much lives has been protected, and how much economic loss has been prevented, making the environmental impact understandable for decision makers. This dashboard proves that climate action is not just automated, it is effective. Okay, so here are our analytics, here are our simulation, and here is our the major dashboard. So this is how we are building the future of urban climate resilience through integrated technology solutions. Thank you. Team Hustler signing off.